smart. Okay. 3 by 2. Do you guys, when you were doing this one, did you notice that there's a term missing? Did anyone notice there was a term missing? Okay. So x cubed minus 6x squared plus 0x minus 10. Okay. X cubed, x squared, negative 6x squared. Oh, that's awkward. I already have it. 0x squared, 0x, 0x. Oh man, I already have that too. 0x, 0, 0. Hmm. Okay. Negative 10 minus 0 is negative 10. I'm actually going to rewrite this because of all this stuff. So I have x squared. I'm not going to write the 0x. I'm not going to write the 0 minus 10 over x minus 6. That one was awkward. But a good one to do together, at least, so you guys feel confident. If that happens to you, it happens. Okay, next one, number 4. I feel like number 4 is not going to be factorable. Do you feel it? I feel it. I feel like the last one was just so perfect. Not going to happen again. Okay, first I noticed that there's a greatest common factor of x, so I'm going to take that out. And then I'm going to take the root they gave me and change that to x minus 2, and then divide. Whew, I had myself doubting there for a minute, because it was weird, but worked out. Okay, so I have the x that I factored out. I have the x minus 2 that I divided by, and now I have x squared plus 4x plus 20. I'm going to sit here and think about the diamond for a second. I don't think it works. No. Okay, which means that that's all the way factored. So now we have, oh, I should set it equal to 0 though. Do it properly. 0 equals x minus 2, x plus 20. Okay, so I have x equals 0, x equals 2. Those are two single real roots there. And now I don't know what's going on with this situation here. X equals negative b plus or minus square root b squared minus 4ac. What did I do wrong? You're the best. You're the best. Never change. Okay. I don't know if I like that news though. Okay, anyway, so this is x equals negative 4 plus or minus 16 minus 80. You're the best. Negative 4 plus or minus negative 64, which is going to be 8i, which after I reduce is going to be negative 2 plus or minus 4i. Okay, now we have to sketch this thing. Then I think I have bad news. I think there is not a bump at negative 2, which means that our idea is, I don't think it works all the time. It's really weird. I actually graphed it before you guys came. This is how nerdy I am. I'm really nerdy, people. I graphed it on Desmos before you came. And interestingly enough, you can't hardly see it, but there's a really weird inflection point right here. If that's negative 2, maybe. I don't know. Um, so what we're gonna do is we're gonna say, okay, we know we have single reals at 0 and 2. We know it's a degree 4. We know it has a positive 8. So we're just gonna go, okay, there should be some sort of situation somewhere. And it doesn't even have to be on this side. It could be over here. I'm not sure. I think the inflection point is a thing, but anyway. And both of my arrows are going up. There are some really weird polynomials. Okay, we are going to use a resource page in here today. It's the one called the sign calculator. You could find that in your packet and then just scoot your packet off to the side. It looks like this 9.1.3 resource page, and then it says the sign calculator on the side. Okay, now I have to tell you I cheated and used a compass. I'm gonna cheat and use a compass all chapter. You do not need to have the circles be perfect. It's okay. I'm a nerd. Now, if you're really, really particular about it, the bottom of a water bottle is a really, really great circle. Just, I mean, you're just using it, but like, if you have a reasonably sized water bottle, you could make a good circle out of that. Please don't feel like it has to be perfect though. It's just me being extra. Do leave a lot of space though. I have a lot of things to teach you in here. A lot of it is like vocab and stuff about the screamer that's gonna be your first time. Also, you're definitely going to want a ruler at some point. So when you're done, get a straight edge. Okay, this is the screamer. And for number 27, if you read the book, it says that Renee and Antonio, sure enough, you remember how I said they had to rush to get it done in time for summer with the foreboding music? Do, 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 do. Okay, it says, sure enough, they came to a screeching halt, metal twisting, sparks flying, and they ended up being 40 degrees from the x-axis. Okay, there are actually four different locations that they could have ended up if they're 40 degrees from the x-axis. And we're just going to estimate our 40 degrees. So hopefully you guys all know that 45 is exactly halfway through the quadrant, right? Okay, so you're going to go 45 and then just back it off a little bit. We're not measuring with a protractor here. We just went to 45 and then scooched our angle down a little bit so it wasn't perfectly through the middle. Okay, and we have two things that we're going to answer in this question. So if Renee and Antonio broke down at 40 degrees, it could be here. It also could be here. It also could be here. And it also could be here for 40 degrees to the x-axis. But first, we're going to find their height. So we're going to find this. And we know the radius was 100 feet. So we're going to put a 1 there, and then we'll move the decimal. So this is opposite over hypotenuse, sine of 40 equals opposite over hypotenuse. Y over 1 is just y. Okay, so go on your calculator, guys, and find me the sine of 40 degrees. Make sure your calculator's in degrees. And round it properly to 3 decimal places. Okay, so if the radius is 1, their height was 0.643. But if it's actually the screamer with a radius of 100, their height would be 64.3 feet up, which is really a lot, by the way. I don't know if you guys thought about how much a 100-foot radius is, because like the ceiling is what, like 8 feet? So like that'd be a lot. That'd be a lot up, very much far up. Okay, anyway. Okay, so there's some vocab and things that I need to teach you here that are really important. But first, what we're going to do is create what I like to call the bow tie. This is your first time doing the bow tie. I want you to make vertical angles with this 40. So take your ruler and extend the line to the other side. Then take your ruler and extend the height of the triangle down. Then line that point up with the origin. Mine's not perfect, but it's okay. This is what I will call the bow tie through this whole chapter. Can you guys see the bow tie? It really helps if you can visualize the bow tie, drawing it in. And all of these angles at the center in the bow tie should be equal. Those are all 40 degrees. And we're going to use these to find the other three locations that Renee and Antonio could have come to a screeching horrible halt. Okay, the first thing that you need to know is that this is 0. This is the loading platform where they got on. And the screamer rotates this way. And this is 90. And this is 180. Is this all making sense so far? Okay, and then what you do is you go 180 and then you back up the train 40 degrees. So this is 140. And how you calculate that is you go to 180, you go all the way halfway around, and then back up 40 degrees. Okay, so Renee and Antonio could have broken down at 40 in quadrant 1. They could have broken down at 140 in quadrant 2. Okay, this is an easy one. How do I get quadrant 3? So you go halfway around and then plus 40 more. And then for quadrant 4, I go all the way around the circle, which is 0 and 360. And I go 360 all the way around, and then I back off 40, 320. Okay, Renee and Antonio could have come to a screeching halt at any of those 4 spots. We don't know where. We do know that their height here would have been 64.3 feet up. We do know their height here would have been 64.3 feet up. We know their height here would have been 64.3 feet down, and their height here would have been 64.3 feet down. Does that make sense to you guys? Okay, so there's a little bit of vocab that we need to write over here. Okay. 40 degrees is called the reference angle. The reference angle is always between 0 and 90. And is between the hypotenuse and x-axis in the triangle. Already messed up. Already messed up. Okay, in quadrant 1, the angle itself is the reference angle. I'm going to use theta as my x here. You can put x if you don't like theta. In quadrant 2, I did 180 degrees minus theta to get my quadrant 2 angle. In quadrant 3, I did 180 degrees plus theta to get my quadrant 3 angle. And in quadrant 4, I did 360 minus theta to get my quadrant 4 angle. All times, yeah. Okay, and then there's another piece of vocab I need to teach you. It's called coterminal. You can basically think of those as little formulas. Coterminal. Coterminal does not mean that you're in an airport and somebody's in the same terminal as you. That's my terrible, terrible math vocab joke for the day. Coterminal means that angles that land at the same spot. Okay, what do I mean by that? So I want to make sure everyone in the room realizes that this angle and this angle did not land at the same spot on the circle. These are not coterminal. This guy's in quadrant 1, this guy's in quadrant 2. But coterminal reminds us that circles and rotation can go on forever. So 40 is coterminal with whatever I get when I go another 360 around this way. So for example, 40 plus 360 equals 400 degrees. This is reminding you that it goes forever to infinity. Add 360, add 360, add 360, add 360. You could also go the opposite direction. Go up 40 minus 360. That would be a negative 320 degree angle. Minus 360, minus 360, minus 360. Okay, anyway, so to calculate coterminal, you take your angle plus 360, not 36, not 36. My brain moved faster than my hand did. Or minus 360, basically forever. Now, I'm going to ask you guys for a coterminal angle a lot of times this chapter. And don't be the kid that goes like plus 360 like 74 times to make me check your work. You could just go once, that'd be cool. Or backwards one time. Two maximum. You're gonna be that guy who's like plus 360, plus 360, plus 360 on the calculator, like plus 77 times 360. Like make me figure that out. That would be really mean. Don't do it. I'm gonna ask you please not to do it. As fun as that might be for you. You might leave me a little like bum on your test and like, see if she can figure that one out. Trust me, I can. I just don't want to. Okay, that took forever, but we're finally done with number 27. 28 would be faster, I think, ish. Luckily, we only have two problems. Okay, so for A, we're just going to steal work that we did from our previous problem up here. So what I want you guys to do is take the sine of 40. We're going to work with 40 degrees again because that's what we've been working with in this problem. So I want you to write sine of 40 degrees equals 0.643. We did that on the calculator earlier. And I want to make the connection between the screamer, which is actually called the unit circle, and the sine wave. So if you could get your resource page out, I want you to locate for me the sine of 40 degrees on your resource page. So to do that, you're going to count over to 40. And then I'm going to take my ruler, go up to the wave, and make a coordinate. Is it reasonable to say that the height of that wave is 0.643 according to the scale on the y-axis? Okay, so what I want to do is I want to do the same thing we did with the unit circle, the screamer, but I want to find the other three angles in the other three quadrants that are the same as the ones we found on the screamer, but I want to do it with the sine wave instead. So I'm going to take my ruler and I'm going to go across because this point right here has the same height. And I'm going to follow that down. This angle is 140. Is that what we expect to see from our previous work? was the second quadrant angle 140 that we found on our paper. Right here, indeed. Okay, now for the other ones, I'm going to have to guesstimate-ish the height. So the height was 0.643, so I'm going to have to figure out where the distance is about 0.643, and I think it's here. Do you guys agree that it's there? 0.643 away? Yeah, I hope. And that is 220. And then the fourth one is 320, which jives with our formulas on the unit circle. I really want to connect how the unit circle and the wave, basically the same thing. Okay, so for B, we're just going to come over here and list them. So 40, 140, 220, and 320. Okay, last thing for the day. We're going to graph each of these angles. We're not going to do it with a protractor. We're going to do it by sketching. We're going to find the other three angles, other three spots on the circle that would have the same angle. Notice I didn't draw circles. I don't need circles. But anyway, okay. First, 0, 180. I suggest that those are the two things that you label on the axes, 0 and 180. And where is 80 about? If this is 0 and this is 180, where is 80? Like almost to 90, right? Okay, now it doesn't have to be perfect. Just make it in this general vicinity. Okay, now if you have other colors, I would switch colors at this moment, and we're going to practice drawing in the bow tie. I'm going to use pencil because it's thinner than flare pen. Oh, it's terrible. It looks exactly the same as what I just drew. That was terrible. Why can't I draw a vertical line today? It was slightly better. I don't know. Gosh, that's awful. Okay. Maybe I'll improve in my other two Math 3 classes. Okay, so we have two goals. We're going to find the other three angles in the other three quadrants, and then we're going to find an angle that's coterminal to 80. Okay. Second quadrant. So I'm going to come over here. I have a formula, or I can use common sense. 180 and then back up 80. (100 degrees) for quadrant 2. And really, that should make sense to you because it's like it went 80 and then it's 10 more to 90 and then it's 10 more there, right? Okay. Quadrant 3. 180 plus 80 is 260. That should make sense because straight down is 270 and it's back 10. Fourth quadrant, 360 minus 80, 280. Oh yeah, that makes sense too, because it's 10 away from 270. Okay, a coterminal angle to 80 would be 80 plus 360, which is 440. Okay. It really helps your brain if you go, like, literally take your pencil, go to 80, and then go all the way around back to 80 to see that coterminal. This is not the only coterminal. There's infinite number of correct answers here, but we're just going to put the easiest one for Mrs. Talbot to find. That's what we're going to do. Okay, do you guys get the gist of what we're doing in these three? Okay, so letter, I don't know, number 2 at this one, the middle guy here. I'm starting out with something that's not in quadrant 1. Ooh. Where is 200 degrees located? So let's go here, 0, 180. What quadrant is 200 in? Third, right. And it's just a little ways into the third. Again, it doesn't matter. Okay, here's the math that you need to do right now. This is the only part of the math that there is. You need to figure out what the angle is here. What's the reference angle? 20. Because 20 is the difference between 200 and 180. So in this problem, 20 is the reference angle. Okay, so now I'm going to make my bow tie. Which apparently I'm just going to struggle with today. I don't know what's happening. Now this one's cool because half of our problem's really done for us. We already have the third quadrant angle. It's 200. This one we know is 20. So this is quadrant 2, 180 minus 20 is 160. And this one is quadrant 4, 360 minus 20 is 340. Okay, what would a coterminal angle to 200 be? We're doing the coterminal to the original one, the original problem being 200. 200 plus 360, 560. Do I have to plus 360? No, I could minus 360. I could plus 360 again. I could minus 360 again. I could plus and minus 360. That would be kind of annoying because I get right back to the same thing. One more. This one is the spiciest. You guys know why it's the spiciest? Can you tell? There's two reasons that it's super spicy. Yeah, negative, and it's so big that you can't actually find it on the circle. Okay, so in this case, this is as hard as this problem would ever get. We're going to actually find the coterminal first. So come down here, go negative 750. And you want to add 360 because you want to get closer. You want to graph it. Your graph is between 0 and 360. So you want to get closer to 360. So I'm going to go negative 750 plus 360. Negative 390. That helped a little bit. I'm going to go again. Negative 30. Okay. Negative angles go in the opposite direction. Negative goes this way. So negative 30 would be right here. Okay. If this is swinging 30 degrees downward, what is the reference angle? How open is this angle right here? It's so easy, it's hard. It's just 30. It's just 30 degrees. Reference angle is 30 degrees. Okay, so now I need to build my other 30-degree angles. Okay. What's the degrees of this arrow right here? 30. You all know it. You're just too scared to say it because it's new material. Okay. What are the degrees of this one right here? 150. We good on the 150? Okay, so second quadrant, So you go 180 minus the reference angle. So what 180 minus whatever's in quadrant one. Okay. So in that case, what's this one? 210. It's 180 plus 30. Okay, and then this one's going to be, we're going to find the coterminal again here. So this is 360 minus 30, 330. Don't forget, these little formulas are up here if you need them. But you need to have an angle between 0 and 90 to plug into those. Okay, now go back to your packet, find the homework, please. I'm going to do the first problem with you. Okay, this is the homework. It's a maze. It's not supposed to take you very long. It's supposed to be fun. Start here. It says find the reference angle at 170. Okay, so come down to this little box. Just make a little sketch. I would label 0 and 180. Those would be the two things I would label. And then it says find the reference angle of 170. So 170 is going to be like almost to 180. Does that make sense? The reference angle is asking for this right here. So if this is 170 and this is 180, what's the reference angle? 10. Okay, and then you come up here and then you go this way in the maze. Okay. Do you want to just keep going together for the next minute or two? Okay. Find the positive coterminal angle of 72. Okay, positive coterminal means you want a positive number. So you don't want a minus 360, you want to add 360. So you're going to go 72 plus 360. Four 32. Are you guys getting the hang of what this is asking? Okay, next one. Find the reference angle of 173. And we can almost just steal our work from number one for that. Okay, so what's the reference angle between 173 and 180? 7. Find the positive coterminal angle of 252. Perfect. Find the negative coterminal angle of 184. So minus 360, because that will get you into the negatives. Okay, anyway, look at all the stuff we did. If this takes you longer than like 15 minutes to finish, you're doing it wrong. It's not supposed to be difficult or long or challenging. It's supposed to be just 15 minutes made fun. So anyway, um, I'll miss you all very much. Have a great grade. I am.